Good afternoon. Welcome back to Energy 101, and we've been talking about energy resources. The reason we've been talking about energy resources is we need to back up. I want to back up and look at the big picture so we don't lose our perspective. Remember that the whole thing got started when we first started the course looking at energy used by society and what society wanted. And due to the fact that we can't create energy out of nothing, we have to go find that energy due to the natural laws of physics that exist in the natural form. So we've been looking at what those natural forms of energy are that we utilize and to supply the needs that society wants, to keep their houses warm, to drive their automobiles, to provide lighting, to provide cooling in our homes and buildings, and to make our lives better. And society and we as individuals are willing to pay a significant amount of money for that energy. But there has to be a tremendous infrastructure behind it, the energy flow, in order to supply us with that energy. So we've been looking at where the energy comes from in this natural form. And we have looked at the hydrocarbon supplies, the nuclear energy supplies, and the renewable energy supplies, and where they're all coming from. This one shows the 2011, these numbers show the 2011 energy resources and where they're coming from. 20% of them of our total energy supplies comes from coal, 26% from oil, 36% from natural gas, nuclear is 9%, and renewables, biomass is 5%, hydros is 3%, hydroelectric dams is 3%. That we don't expect that number to change significantly. Due to all kinds of limitations, we don't expect to build any more dams. You can't get permitting, and the environmental issues people don't want to deal with. And so the hydroelectric situation and the energy we're getting from the dams is pretty much a fixed situation. Wind energy is, we're getting a little over 1% now. Geothermal, which is energy from the earth when we drill down in the earth. And then we have solar energy. Notice that wind is about 10 times as much as solar. Even though you hear a lot about solar, and we've had a lot of emphasis on solar, wind is still supplying almost 10 times as much energy to our society as solar is. And that's because of the cost of solar. The cost of solar is significantly more than wind in general. And so that's where the growth has occurred. We're still in general a free enterprise capitalistic system, and the cheapest solution that provides, in this case, renewable energy is the one that will be utilized. And that is generally wind over solar. But solar is coming along and the cost is coming down. Here's our energy resources shown as a pie chart. And we've already seen oil is about 39%, natural gas, and then coal. And then there's the hydro that I mentioned before at 3%, and nuclear is about 8 or 9%. Biomass, I already mentioned, is about 3% in 2002. And here, wind in 2002 was about 0.1%, 1/10 of 1%, which is a small number in 2002. Well, how did it change in 10 years to the end of 2011? By the way, if I hadn't mentioned it, I deal with 2011 because I like to look at whole year periods. When you start looking at monthly data, you get a lot of scattering the data, and it's very difficult to make any hard conclusions from monthly data. So I like to compare year on year, and so we'll be getting the year data for 2012 from the EIA, Energy Information Agency, sometime around March or about the time this course concludes. But here's how the pie chart looks, and you can compare it one with the other. That's the 2002, this is the 2011. And One thing I wanted to point out is that the numbers have changed slightly, and this shows how they've changed on a one-to-one basis. The blue bars right here show how much has what percent we are getting from each resource. Coal, and our percentage from coal has gone down from about 23% or 24% down to about 20%, so we are relying less as a percent on coal. And by the way, the total energy consumption in 2011 is about the same as 2002. It climbed to until about 2008 when the recession dropped it, and now it's climbed back to where it's about the same as 2002. So 2011 total energy consumption is about the same as 2002. And this is showing the percent of that total energy consumption of natural resources and where it comes from. You see natural gas has gone up. It's gone up about the same amount that coal has gone down. That's been good from global warming because natural gas power plants, which is primarily where it's gone, and coal has been reduced, it produces about half as much CO2 for each unit of electricity produced as coal does. And that's due to the difference in the molecule being a CH4 for natural gas and coal being all carbon. Oil, you can see the percentage for oil has gone down slightly, and this is due to more efficient automobiles over the 10 years. And even though we are driving more miles, and it's also, we've changed our driving patterns. Nuclear is about the same from 2002 to 2011. Biomass has actually gone up, as you can see here, because there's more incentive now with the economics and there's more government incentives. Hydro is about the same, and wind, you can see, was insignificant. In 2002, it was down around 0.1%, whereas now it's, as I showed you, about 1.2%. Geothermal, you can see, is very small, and solar is very small. I put these out here to show how much they impact our total energy consumption. So though we've heard a lot about solar, and we've put a lot of emphasis on it, there's a lot of research and development going on, there's a lot of effort to drive costs down, it still is pretty much an insignificant, making an insignificant contribution to our total energy picture about as far as how much it impacts our oil consumption and our natural gas consumption and coal consumption and nuclear consumption. But you got to start somewhere, and even though the amount of wind has gone up a factor of 10 and solar is about the same, it's still a small fraction, very small percentage, around 1% or less for both wind and solar each, of where we get our energy resources from. So that recaps the energy sources that we have and we currently are getting our energy from, and now we'll look from here forward at things like the conversion of this raw form of energy, be it wind or solar, into a form that we want it and can use it. And that will, because we'll see that there's some limitations regarding how we can convert it and how much we can convert it and the efficiency with which we can convert it and the cost that we can convert it. Okay, thanks for your attention. Bye.